right, so let's prepare for next Wednesday on Chapter 6. It's open book, open notes. I'll do that for you because of, all that situation that happened before, when your professor didn't want to teach you anymore. And, okay, that's all. All right. And don't forget to sign your attendance sheet. Okay. So as I gather myself and compose myself, I want to talk about electron configuration. Okay, the electrons are going to march in. Okay, they're going to go one by one by one by one by one, and then they may pair up, pair up, pair up, pair up, pair up. Okay? And if it's all paired up, they'll go to the next level, then the next level, and the next level. Okay, so the key to electron configuration, you just have to know the order. Okay, if you know the order in which the electrons go in and how they go in, this should be fairly simple. Okay, you just need to know the order of the electrons going into their orbital. Okay, once again, all you need to know is the order in which the electrons go to their orbital. All right, so this is how they'll go in. Okay. Okay, do you remember the orbital? Okay. Okay, just remember that S. So I'm just going to draw a diagram here. We have energy on the y-axis. So we have shells and orbitals. Okay, we already know these orbitals. Okay, one of them is the s orbital. We're just going to call this 1s. Okay, 1s. Okay, that's the lowest energy orbital. Okay, and this in our periodic table, this would be 1s. Okay, so how many electrons are in hydrogen? Okay, 1. Okay, so what is the electron configuration of hydrogen? Okay, the electron configuration of hydrogen is going to be 1s1. Okay, I'll just put it in brackets here. That 1 superscript symbolizes that 1 electron. So we will do the electron configuration of several of these elements for this entire class. Okay. So let's go to helium now. Helium. How many electrons in helium? 2. So where will that second electron go? Okay, it's going to pair up. Okay, it's not going to go to the higher 2s. It's going to pair up. Okay. So what is the electron configuration of helium? 1s2. Okay. I want you guys to realize that for helium, 1s2, this represents a filled n equals 1 orbital. It's filled. If it's filled, we say helium is content. We say helium is what is called a noble gas. Okay, for helium, there's no reason to pick up another electron or lose another electron. There's simply no reason. Okay, it's a noble gas because it's filled its valence. The valence for helium is 2. Okay? So it's happy, helium at 1s2. All right, the next element here is lithium. Okay, where do you think that third electron will go?
It'll go to another configuration.
It's going to go, 1s is filled, so it's going to go to 2s. Okay, so what's the electron configuration of lithium? It's going to be 1s2, 2s1. But what is 1s2? 1s2 is nothing more than helium. Okay. So that is the electron configuration for lithium. Let me take another sheet of paper here. Okay, why do you think lithium would want to be +1? We have lithium, and then we have lithium +1. What happens when lithium becomes +1?
It loses an electron.
Okay, very good, Sebastian. If it loses an electron, what will it become? It will have the same electron configuration as helium. This is why lithium likes to be +1. Okay, this is why sodium likes to be +1. This is why potassium likes to be +1. This is why every group element in this group likes to be +1. So we will say lithium +1 and helium. Okay, they are both 1s2, and we'll call them isoelectric. Same electron configuration. Isoelectric. Isoelectric just means the electron configurations are the same. Lithium and helium is isoelectric. You see, when lithium loses an electron, okay, it loses an electron. There, poof, the electron is gone. It becomes lithium +1, and it's noble. Okay, it's noble because it's lost that electron. It's now 1s2. Isoelectric, same electron configuration. All right, let's continue down our list. Okay, next on our periodic table is beryllium. Okay, where do you think that fourth electron will go?
The S.
It will pair up with S. So the electron configuration 1s2, 2s2. But what is 1s2? It's helium. Am I correct, Liz? Yes, ma'am? Yes, it is. Okay. All right, so let's go back to our periodic table here. So we have the 1s. So this would be 1s1. Okay, 1s2. I'll scan these for you a bit when the lecture is over. We're going to call this 2s. Okay, for 2s1, 2s2. We're going to hop and skip over to boron number 5. Okay, now this has 5 electrons. So 1, 2, 3, 4. Where will the 5th electron go? Very good, the p shell. Okay, so the next, remember, okay, very first thing in this class, the order in which these will go. They'll first go 1s, 2s. They'll first go 1s, 2s. Well, the next one on our list is 2p, so it's a little bit higher energy level. And how will the electrons go? Okay, they'll go spin up. Okay, so 1, 2, 3, 4, 5. That accounts for the electrons in boron. So what's the electron configuration for boron? 1s2, 2s2, 2p1. This is element number 5. Okay. This is going to be helium 2p1. Okay. This is the 2p block. What about carbon? Anybody here taking organic chemistry? Okay. Organic chemistry is all about the carbon. All about the carbon. The central atom is carbon chemistry. Where will this 6th electron go? Well, 1, 2, 3, 4, 5. Where will electron number 6 go? In which carbon has 6 electrons? Neutral. Okay, 2p. Okay. So carbon is going to be 1s2, 2s2, 2p2. We'll just call it helium 2s2, 2p2. Okay, this is 2s2, 2p1. Okay. All right. Let me go over here. Okay. center sheet. Let's go back and talk about beryllium. Okay? Okay, why would beryllium like to be +2? Not lose 1 electron, but lose 2 electrons. Okay, let's say it loses not 1 but 2.
For it to be stable?
Okay, yeah, to form a +2 ion. Okay, if beryllium loses 2 electrons, what will it be? It will be 1s2. What element is 1s2?
Helium.
Helium. So beryllium +2, lithium +1, and helium are isoelectric. Same electron configuration. You see, when beryllium loses 2 electrons, it becomes noble. When lithium loses 1 electron, it becomes noble. Helium is already noble because it has a filled n=1 shell. So this is why all of these like to be +1, and this is why all of these like to be +2. Okay? We're hopping over to the 2p. Okay. Now, boron, carbon, these other guys, they don't like to really form ions. Well, these ones do. We'll talk about that. Okay? Because they can achieve nobility pretty easily. And this can achieve nobility pretty easily. This can achieve nobility pretty easily. When I say nobility, become like a noble gas. Okay, where did we leave off now? Okay, next one is nitrogen. Okay, where will nitrogen go? So what's the electron configuration for nitrogen? Very good. Okay. All right, what's next on our list? Oxygen. Okay. Right?
Yep.
1, 2, 3, 4. 1, 2, 3, nitrogen. 4. Something's not right here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay. All right, where will oxygen go?
Pair up.
Now it's beginning to pair up. Very good. Okay, so what will oxygen be? This is the next on our list. Oxygen. 8 electrons.
Oxygen will be
1s2, 2s2,
1s2,
and 2p4.
2s2, 2p4. Very good. Okay. Let me ask you guys a question here. Okay, this oxygen. Okay, if this oxygen, if it gains 2 electrons, not loses, gains 2 electrons. Okay, if it gains 2 electrons. Okay, what will it have?
It will be oxygen negative.
Yes. And how many electrons will it have? 10, if it gains 2 electrons. So this is why oxygen, as the oxide ion, would like to be -2. If it gains 2 electrons, what will it become? Noble. The noble gas, yes. Very good. And specifically, that noble gas is neon. Okay, so this is why some of these elements like to be -2. Okay, they like to be -2 because if they gain 2 electrons, they become noble. All right, let's talk more about this. But first, let's go to fluorine. Okay, what will fluorine be? Where will that electron go? There. And what is fluorine? Helium, 2s2, 2p5. Everyone see that? Okay. What happens if helium gains an electron? I'm sorry, fluorine. What happens if fluorine gains an electron? Not gain 2, but gain 1. Very good. It becomes like a noble gas. So here I'm going to have fluorine gain an electron. Not 2, just 1. Okay. If fluorine gains an electron, it will have 10 electrons, and it will be noble. So that's why these guys, we call them the halogens, they like to be -1. -1. And these guys like to be -2 because you see, class, this is how they attain nobility. Okay, when I say nobility, they'll have the same electron configuration as a noble gas. All right, we got fluorine. Here we go. Neon. Okay, where will neon go? Okay, 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will fill up the n equals 2 shell or n equals 2 orbital. Very good. So we'll call it helium 2s2 2p6. And I'm going to say filled n equals 2 shell. Okay, the principal quantum number is 2, and we filled the shell. So neon is like very, very happy. Okay, neon is very, very happy. Okay, so O minus 2, F minus, and neon, Ne. Okay, we're going to call them isoelectric, same electron configuration. So we filled the n equals 2 shell for neon. Well, let's go on. Sodium. Okay, how many electrons in sodium? Where will that 11th electron go? We know 10 of them will go like this. The electrons go marching in. We must know the specific order. It's going to fill up the 3s shell because this is next on our list. This is what we need to know. Again, the order in which they go. Okay, so it's going to fill 3s. Okay, 3s. So what's the electron configuration of sodium? Very good. Okay. But what is 2s2 2p6? Neon. Okay, so we're just going to call it neon 3s1. The abbreviated form. But you can say what you just said, which is fine. 1s2, 2s2. What did you say? 1s2, 2s2, 2p6. You can say that, but all right. Why does sodium like to be +1? What happens if sodium is +1? Here I'm going to have sodium lose an electron. It becomes a noble gas. Which noble gas has 11 electrons? It loses 1 to become 10. So now we say O minus 2, F minus, and Na plus have the same electron configuration as neon. This is why Na likes to be Na plus, because it will have a filled n equals 2 orbital. It loses this valence electron, and bam, it becomes noble. So these guys would have the same electron configuration as the noble gas neon. Okay, up above, these guys will have the same electron configuration as the noble gas helium. And on we go, okay? Just be patient. There's more to come. How are we doing on time?
It's 9:29.
9:29, okay. I got 20 minutes. All right, what's next here? Magnesium. Okay, magnesium is actually found in our body, and it's found in our body as Mg plus 2. Okay, why do you think it's Mg plus 2? Because that's the most stable form. Okay, the most stable form. What's the electron configuration of Mg by itself? Neon 3s2. Okay. All right, we filled 3s. Now we got to hop, skip, and jump over to aluminum. This is the 3p block. 3p. Okay, because you see the 3s shell is filled. We must know the order, so now it's going to go to 3p. Okay, so 3p is a little bit higher on the energy scale. 1, 2, 3. And now the next one on our list is aluminum. Aluminum. So aluminum is going to fill this one. And what's the electron configuration of aluminum?
It is
Neon, 3s2, 3p1. 3p1. Got it? Okay, what about next is silicon. What is silicon? Where will that electron go? Silicon has 14 electrons. So electrons are marching in a very specific order. Okay, silicon. What's next?
chromium. Not chromium, phosphorus.
Phosphorus P is next. Okay, phosphorus 3p3. That's where that electron will go. All right. Now where will the electrons go for sulfur? Okay, we already filled up 15. Where will the 16th electron go? Pair up. Okay, very good. Next, chlorine, right? Yeah, chlorine. Okay, where will chlorine go? Pair up. Okay, chlorine will pair up. And then, what's next? Argon. Okay, what will argon be? (3s2), 3p5. So we have here what shell that gets filled up? Okay, this is a filled n equals 3 orbital. So we filled it all the way to argon. Why do you think S would like to be -2 and Cl be -1? Okay, so S would like to actually gain 2 electrons to be S -2. Cl would actually want to gain 1 electron to become Cl-. Okay. Why will they do that? Because they will become noble. They will have the same electron configuration as the noble gas argon. Okay. And this time it's going to be argon, the next noble gas. All right, we filled up 3p. Now where will it go? Where will the next electron go? Okay, it's going to be potassium, which it will fill up the 4s shell. Okay, 4. So we're going higher and higher in energy. 4s shell, and we have 19 electrons. The 19th electron will go there. Okay, so what's the electron configuration of potassium K? Okay, you can go 1s2, 2s2, 2p2, 2p6, 3s2, 3p6, but we realized that 3p6, 3s2, 3p6 is argon, so potassium is nothing more than argon 4s1. Why would potassium like to be plus 1? Okay, we have potassium K plus in our bodies. It's found a lot in bananas, so they say.
So it can be argon.
So if potassium, here I'm going to have it lose an electron. It becomes K plus, so it will be noble. Same electron configuration as argon. Okay. What's next? Calcium. Okay, everyone knows calcium. Okay, we also have calcium in our body. And calcium has an electron configuration of,
Argon 4s.
oops, just calcium. Argon 4s2. Why would calcium like to be plus 2? It's found as an ion in our body. We are going to have calcium lose not 1 electron but 2 electrons. Becomes calcium plus 2. Why would it like to be calcium plus 2? It will be a noble gas, and that noble gas is argon. Okay, so these are the reasons why these like to be plus 1, these like to be plus 2, and these like to be minus 2, and these like to be minus 1, because they can achieve nobility, have the same electron configuration. All right, what is next here? Okay, it's not 4D, but it is 3D. Okay, this is called the N-1 block. N-1 block. So what is the N-1 block? Okay, it's all the things that are in this orange box. Okay, these are called the transition metals. Transition metals. So after 4s, what will they fill? 3d. And how many slots does 3d have? Okay, 5. Okay, 5. Okay. All right, and then what would titanium be? So what is what is that? Scandium. Okay, let's go. Okay, what would scandium be? Argon, 4s2, then what? 3d1. Okay. Now you can also write it this way. Okay, both ways are correct. 3d1, 4s2, because some people like to have the principal quantum number the same, sequence. 3, 4, 3 comes before 4. But the way the electrons go in is 4s2, 3d1. This is just an energy level, that's all. You can write it this way or this way. I like it this way. I like the 3 coming before 4, but you can write it this way. That's totally fine. All right. How about the next one on our list here? Titanium. How would you guys write that? 4s2, 3d what? 2. Okay. This would be titanium. Okay, what's next? Vanadium. Okay, what's next? Chromium. Okay, what's next? Manganese. Okay, what's next? Iron. Everybody likes iron. What's next? Cobalt. Okay, what's next? Nickel. Right? No, we're still in the D's. So we filled it all the way up to here. Okay, so 3D1, 3D2, 3D3, 3D4, 3D5. What happens after 3D5? They start to pair up. Very good. 3D6, 3D7, 3D8, 3D9, 3D10. Okay? All right, so we got all the way up to zinc. Okay? Now, after zinc, where will these electrons go for Ga gallium? Okay? Okay, we got our 30. Now where will it go? The 3D is filled. Where will it go?
4B.
Now we'll fill up the 4p shell. Okay. So now we'll fill up the 4p shell, and we'll just go this way. 1, 2. A little bit higher energy. Okay, 4p. All right, what about next one, germanium? 4p2. What about arsenic? 4p3, very good. Selenium? Pair up. Bromine? Pair up. Krypton? Okay, so we go all the way to krypton, and what will we have?
We will have a
Noble gas. And what shell did we fill? Which shell did we fill up? 4p. And what is completely filled?
N4.
Very good. Okay, we have a filled n equals 4 orbital. So that would be for krypton. Okay. All right, after 4p, where will it go? Back to 5s. Okay. Why would bromine like to be Br minus? And why would Rb like to be Rb plus and Sr strontium be Sr plus? They'll be like krypton. So here I'm having bromine gain an electron to become Br minus. I'm having Rb rubidium in group 1 lose an electron to become Rb plus. Here I'm having strontium Sr gaining 2 electrons, losing 2 electrons. Losing 2 electrons to become Sr plus 2. Okay, again, you're right. Nera is correct. It will become like krypton. Okay. So all of these are isoelectric electron configuration to krypton. Isoelectric means same electron configuration. And this one would be krypton. Right, so after 5s, 5s1, 5s2, where will they go?
4D.
Very good. 4d. Okay, fill up the 10. Pair up after 5. And then 4d, where will they go? 5p. After 5p, where will they go? 6s. Now something weird happens here. After 6s, they will go to the n minus 2 block. Okay, this is the n minus 1 block. This is the n minus 2 block. These are where the f orbitals stand. Okay, so after 6s, where will they go? 4f. Okay, how many slots are in F? 7. 1, 2, 3, 4, 5, 6, 7. Okay, so they'll pair up like this. And then spin down. Okay. So after 4F, what will they fill? 5D. Okay. 5D1, 5D2, 5D3, 5D4, 5D5, 5D pair up, 5D6, 5D7, 5D8, 5D9, 5D10. They filled up 5D10. Where will the first electron in this element thallium go? 6p, 6p1, 6p2, 6p3. Pair up, 6p4, 6p5, 6p6. Where will the 87th electron go for francium? The 86 electrons will go marching all the way to 6p. And then where will this electron 87 go? Okay, 7s1, 7s2, and then they'll go to 5f. Okay, so there's a little detour here. Okay, these are called the lanthanides and actinides. I do not know much about these, But I do know that some of these down here, they're used to make the materials in iPhones or smartphones or whatever phones. Particularly, well, I don't know. I don't know all of them, but anyways. Okay. So I think these are found in caves, and they send little kids to go to the cave to get this material so that people can have their Apple phones and stuff. But uranium is here. So anyways, these elements have f orbitals that house electrons. All right, from after 7s, they'll fill up the 5f orbital, which has all these crazy shapes and distributions. After 5f, where will they fill up? 6d, and your periodic table doesn't have all these yet, but then they'll go to 7p. Okay, so that's the order in which they will go. Okay, once you know the order in which they will go, it should be, I hope, no issue for finding the electron configuration of any element. Okay. Okay, what time do we have, Isaiah? Yes, ma'am.
I'm sorry, just recap. So it goes from 6s to 4f.
Correct.
5p,
Yes.
and then back over to 6p.
Yes, and then from 6p where?
Over to the 7s, then back to 5f.
And then?
Up to 6d, then 7p.
Yes. That's the order in which they go. Very good. What time are we having here?
It's
9:46. Something on the study guide. I think she has some problems. Can we go over two of them? What is the electron configuration? I saw that, but I don't have her study guide with me. Anybody have the study guide? The chapter 6 one? Yeah. Can you give me one? Blake?
No, I got it.
Yeah, give me some. Give me.
It says, please write the following unabbreviated and abbreviated electron configurations for the following elements.
Okay.
And the first one is phosphorus.
Okay, can we do phosphorus? What's the electron configuration for phosphorus? 3s2, then what? 1, 2, 3, 3p3. Okay. Okay, what is 1s2, 2s2, 2p6? Okay, so this is what will be for phosphorus. Okay, neon 3s2, 3p3. Okay, so we have the neon that's going to fill up the 10 electrons. And then 11, 12, 13, 14, 15. 3s2, 3p3. Okay, next one, sir. Molybdenum, 42. Molybdenum is 42. Okay, phosphorus is 15. Okay, so molybdenum, okay? Okay, we can go all the way to that. Yeah, you guys can do that. Let's do the quick one first. Krypton. 5s1. 1, 2, 3, 4d4, right? 1, 2, 3, 4. 4d4. Is that what? That's what I'm getting. 5s2, 4d4. 1, 2, 3, 4. So chromium and molybdenum, as well as copper and silver, have some exceptions. I'll go over that on Wednesday, but there is, you can also say 4d5. You can say 5s1, 4d5 for that one, or 5s2, 4d4. So actually both of these are correct. Technically, this is right because this is the lowest energy. 4d5, 5d1, 5s1, 4d5. I haven't explained it, but these ones over here are exceptions. They march in a very specific order, like I've been telling you, but to achieve just a slightly more stable electron configuration, some of the electrons, especially for these three and these three, will hop. So 4d5 is more stable than 4d4. So I'll go over this on Wednesday. But if you wrote this, that's fine. If you wrote this, that's also fine. I'm guessing you saw that from the internet. But there's a reason why They also have a 45. Okay. Next one, or shall we go?
It's 950.
950. So we'll go over these 6 on Wednesday. I'll talk about periodic trends, and I think that's it. I'll be done with it. You guys can take your test. And make sure you sign your sheet. The lab, if you're in the Monday lab, if in Howard's lab, it's an electron configuration packet, so you don't have to come to lab.
You gotta print it out, do it.
You got to print it out and do it. Okay, that's
Same thing for tomorrow too.
When is that?
tomorrow. My lab is something different.
When is it?
I think she has it due the following week.
I'll put some next week.
Yeah.
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 I remember asking you this before, but I don't remember right then. So
Yeah.
what can I do for like extra credit to look up my grades?
Well, I'm giving everyone 100s if they turn in their study guides. So,
Just do the study guide?
yeah, those are free points. But do it honestly, do it for the learning.
Thank you.
Yeah.